So this is a finite state machine that represents the busy beaver problem that we could look at using a Turing machine. So here I've got the finite state machine with the rules. So I've got my starting state A. If I read 0 on the tape, then I write 1 and I move right. If I read 1 on the tape, I write 1 and I move left. And that takes either of those take me to state B. If I'm in state B, if I read 0, I write 1 and I move left. If I read 1, I write 1, I move right, and we halt. So if we look at the tape here, we're in this position. So starting off in A, we read 0, so we're going to write 1 on the tape, and we're going to move right. So now we're pointing here. So we can also write down that we're now in state B because we transitioned here. So we're in state B, we read 0, we write 1, and we move left. So we're going to write 1, and we're going to move left. So we're going to move back here. And we're now in state A again. So we're in state A, we read 1, we write 1, and we move left. So we've read 1, we write 1 again, so we keep the 1 there, move left. We're in state B. So we're now just here. So we're in state B, we read 0, we write 1, and we move left. We're now there. So we're back in state A. So we're in state A, we read 0, we write 1, and we move right. So this one's becoming a 1, and we're going to move back here to the right. We're now in state B. So we're in state B, we read 1, write 1, we move right. So my head's going to end up here, and we've halted in the halting state. So we've written 4 1s on the tape. So this is called a 2-state busy beaver. So if you were to write a 3-state one, or a 4-state one, or even a 5-state one, you would find that you were writing a considerably larger number of 1s onto the tape. And the busy beaver problem is a form of halting issue, because once we get to a certain number of states, it's not really possible to tell if it will stop. And in fact, it's the kind of function that grows so big so quickly that we would find it very difficult in the real world to store all of the data that we needed to store. Of course, in a Turing machine, this tape, which represents the memory, is infinite. So an infinite amount of memory is what makes the Turing machine the best model of computation. So it's better than what we've got on our desktop because we don't have that much memory. So this is just the conceptual idea of a 2-state busy beaver. Now you could look up how to write a 3-state or a 4-state busy beaver. You might even decide that you can write a program that does this as well. But this is something that is interesting in the field of whether something halts or terminates, so how computable things are.